Testing, testing. Hello. Hello, hello. Testing. Hi. I'm back. Oh, my stylus. I lost grip of my stylus. Hello, good morning, or afternoon, or evening, wherever you are. We are continuing our Leetcoding, the blind 75 today. But I thought it'd be useful to have a review day today, because, you know, what good is it to do Leetcode problems, but forget about it the very next day? So we've done all of the array problems yesterday. Hello, hi Blue Flame Art, hello. Welcome to the stream. So we've done all the array problems in blind 75 now. I think I want to review them. Let's see, I've written down the ones where I've had the most trouble on. Which reminds me, if my list isn't completely updated, I still need to add container with most water. Hello Blue Flame Art, how are you doing today? I hope you're having a good day. Blue Flame Art says, wanted to drop by real quick. Gotta read my networks textbook though. Oh, all good. Dang, thanks for still stopping by. I appreciate. Excuse me. I'm probably not gonna implement directly all of the ones I want to review. I'm probably just gonna say it out loud or write pseudocode on my tablet. Maybe for just one, I'll actually try to implement it. Okay, so starting from two sums, this one was kind of simple. The problem was given an array of integers, nums, and an integer target, return indices of the number such that they add up to target. You may assume that each input would have exactly one solution, and you may not use the same element twice. You can return the answer in any order. Okay. So I think we could just iterate through the list once, and then use a hash map to keep track of which elements we've already seen. The key of the hash map would be the number that we've already seen, and the value would be the index of it. So whenever you come across, when you're iterating through a number in nums, you would be like, okay, have I seen my sort of supplement, the target minus me? Have I seen it before? And if you've seen it in the hash map, return my index and return my index. Sorry, I just solved Dragon's comment. Solved n queens, but I haven't solved the two sum. Oh no, today is review day. So we've just completed all of the array problems in blind 75, so I'm doing a review day, basically. Yeah, I'm basically just gonna... Oh no, it's all good. Yeah, I'm just gonna either talk or pseudocode these, maybe implement one. So yeah, that's two sum. For every one in nums, if I've seen my complement in the hash map, return my index and the complement's index from the hash map. That's basically it. Best time to buy and sell stock. I wrote down that this one gave me some trouble, but you're basically supposed to iterate through everything once, keep hugging the minimum, keep track of the newest minimum, and then keep subtracting myself from the most recent minimum. I believe that was the algorithm. Hold up, did I write down how to do this? Were these my notes for best time to buy and sell stock? Yeah, this was it. Best time to buy and sell stock. Yeah, I think that was the algorithm. Just hug the minimum and then subtract me from the most recent minimum. That should have been it. Should I even? I'm starting to feel doubt about just saying it out loud. Maybe I'll try to implement this one too. Okay. For int I is equal to 0, I is less than prices dot length. I is I plus plus. We want to store our local minimum. Local min is equal to, are all the prices greater than 0? Prices is greater than 0, okay. And then we want to track our best profit too. Best profit is equal to 0, I guess. Okay. So for every num, we need to update our local min. Local min. Oh, actually, we could instantiate local min with prices 0 and start from 1. Local min is equal to best profit is equal to math.max my current best profit minus my current best profit and my current prices I minus my local min, and then update local min, math.min, my current local min, and my current price. Return the maximum profit you can achieve from this transaction. Okay. So return best profit. And I just realized you can't see the code. Let me move it to a better spot. Okay, I'm comparing my notes. For price, if buy price is greater than price, buy price is equal to price. Aren't we returning the maximum profit? Okay. Best profit, price minus buy price. Why does this feel not right? Should I just run in and see what's going on? Oh, right, I need to log into Leetcode again. Give me 1 second. Oh wow, it worked. And it beat it 70%. All right. I don't know why I was doubting myself. I guess there was doubt because maybe I kind of forgot the intuition behind this problem, but I still remember the general idea of it. All right, very cool. Next up, contains duplicate. That sounds pretty simple. You just traverse through the list, maintain a hash set of everything that you've seen before, and for each element, check the hash set. If you've already seen it before, return true. If you've seen it, otherwise, if you got through everything, return false. Yeah, pretty simple. Product of array except self. Oh, this one was the one where you kind of had to make a prefix and suffix. Was it prefix and suffix? I think you had to maintain a prefix of the products starting from back. Okay, you know what? Let me draw this out. I should name all my layers too. Product of array except self. Product of array except self. Oh, this is the problem, by the way. Given in an integer array nums, return an array answer such that answer I is equal to the product of all the elements of nums except nums I. The product of any prefix or suffix of nums is guaranteed to fit in a 32-bit integer. You must write an algorithm that runs at O of n time and without using the division operator. Okay, so the example they gave was 1, 2, 3, 4. So brute force would obviously be for every element in the array, skip me, multiply everything else. So for 1, you would have to multiply this. For 2, you would have to multiply this. For 4, you would have to multiply this. But you would notice that there's some overlap. You're repeating operations. For example, you multiply 3 times 4 2 times. You're multiplying 4 by itself 1 time. I guess that's fine. But I guess it gets worse for longer examples. So what you want to do is you want to kind of dynamic program this, maintain a hash map key to value, where key is the index that you're starting at, and value is the product of everything from the start index to the end. So for example, a key of 2, you would store the value 2 times 3 is 6, 6 times 4 is 24. For 3, you would store 12. For 4, you would store just 4. Maybe that's optional. Okay, so what you would do is, when you start the problem, first iterate backwards through the list and then populate the hash map. Like, first you get 4, and the 4 times 3, store that, and then times that product by 2, store that. Yeah. And then iterate another times, but forward. So for every number, so for 1, you would just return index 2 from hash map. For 2, oh, okay. You would need to maintain int a prefix product locally. No need to cache it because you can figure it out on the fly, but it would start off as 1 prefix sum of everything but 2 would be 1 plus cache 3. And then from 3, it would be 2, update your prefix product, plus cache 4. That should be it. Should I bother implementing this? I feel more or less comfortable with this. Let's see, have I done this? Can I find my notes for this in the past? Yeah, my notes are basically that. I think I maintain a prefix cache too, but I later found out that this wasn't needed. Your last submission beats 7% of other submissions runtime. What was my solution? Oh, here's my solution. Okay. Oh, I did do a prefix cache. But on second thought, I don't need it, right? I can just figure it out on the fly while I'm multiplying. Okay, nice. Next is maximum subarray. I think this one kind of messed me up too. Given an integer array nums, find the subarray with the largest sum and return its number. Wait, my memory is failing me. How do you do this? the subarray with the largest sum. Don't you just go through every one of the numbers one by one, and the largest sum, and if your current sum dips below negative, like less than 0, then you discard your current sum, and then you start anew. You reset the sum to 0. Find the subarray with the largest sum and return its sum. Low effort says John code. What's John code? Local max is 0. Max is equal to min underscore value. For every num in nums, local max plus equals number. Right, update the max. If the local max is less than 0, then reset the local max to 0. Yeah, okay. I got the algorithm down. Level says Screamer in OBS. Oh wait, is my audio peaking? Uh-oh. Hello, testing, testing. Wait, it's not reaching the... Ah, I see what the problem is. I had my Chrome hidden the entire time. Dang it. Well, thanks for making me check OBS. Okay. Maximum product subarray. I think this one messed me up a lot too. Given an integer array nums, find a subarray that has the largest product and return the product. The test cases are generated so that the answer will fit in a 32-bit integer. Oh yeah, for the people coming in now, welcome, hello all. Today's review day. I'm just going through, because we just finished all the array problems in Blind 75, right? So I thought it would be a good idea to review them. I'm not going to do all of them, like type out all the code. I'm just going to either say what the solution is or type out the pseudocode. Oh, did you win interview? No, I don't think so, unfortunately. You're talking about the interview I did 2 days ago? Nah, it wasn't the best interview. Let's see. They ended up giving me not a lead coding interview, but a multiple choice interview. It was like a L9 exam, multiple choice with like 50 problems. Yeah, it was a Java multiple choice exam, and it was so dang hard. I have never been so happy to see a recursive algorithm problem. Like they just gave me a recursion problem. They gave me a recursive method and inputted some inputs to, and they asked me to figure out what the output would be, what would it print. That was like the easiest problem on that. Otherwise, they asked me a lot of very specific questions on classes I've never used before. Yeah. What classes did they? I think they asked me some Java graphics. I forgot what it's called. Some canvas. Like which one of the following is the correct way to instantiate a canvas or something? They also asked me some threading questions, which I didn't know. But yeah, a lot of I think they expected you to have some very deep experience with Java already, so definitely not getting that one. But yeah, that one was very difficult. Yeah, I have been lead coding. I haven't been studying specific Java classes. But it's okay. Most companies don't do that, right? They just lead code you. Hopefully the other interviews will go better. I've been told that most companies are not like that. Yeah, that's how that went. Maximum product subarray. Find a subarray that has the largest product and return the product. Were you told by someone who was going through interviews recently or 20 years ago? Oh, very recently. Like, within past year. That's how I was recommended Blind 75 Leetcode 2. I was seeking out advice from someone who's been job searching recently. Lola says, but interviews are just pretense either way. You mean pretty intense or pretense? Pretense. An attempt to make something that is the case not appear true. Oh. Yeah. I guess most of the time, while you're actually on the work, you won't actually like solve Leetcode questions, right? Lolo says, are you ESL? English second language? No. Does it sound like I'm ESL? English is my first language, but I do recognize that I might have an accent because I grew up in an area where it's all Asian people. So all of us here might have some Asian accents. Level says it doesn't. Oh, what made you question if I was ESL though? Find a subarray that has the largest product and return the product. Okay, I remember this one. You had 2 pointers, right? One starting from the front to the back, and then one starting from the back to the front. You keep accumulating your current product, and if you get 0 for any of them, then you reset your current product, because 0 is just going to drag everything down to 0. You keep the negative numbers in this case because you still have a chance to multiply to a negative number. Like if you come across another negative number, it could return to a positive. So you keep that. I think the reason you multiply from front to back and then back to front again is that what was the reason? Oh, sometimes negative numbers affect you early, and it would capture the case where you don't multiply the negative number. I think that was the intuition. What were my submissions? Oh, this was the one where I had the overflow, right? Okay, this was the solution. Right. Lowell says, now that I think about it, you have a cadence like Asian American people I know, like some. Yeah. I've actually watched some videos on the so-called Asian American accent. Apparently, it's hard to pinpoint exactly where the accent comes from, but there's an accent. Maybe it's like the way, the tone of our voice, or cadence, like you said. So you maintain a local product at 1, maintain your current max, multiply from the front to the back, and if it equals 0, reset the product, and then from right, maintain your local product. If local product is equal to 0, reset local product. Okay, find the minimum in sorted array. Yeah, all the sorted array ones really got me. Okay, I might pseudocode this one, because I remember this one is tricky. Okay, what do we do here? I'll rename this layer to find minimum rotated sorted array. Okay, this is a binary search, so we start from I here, and then we put our J here, and then our M here. Okay, what were we doing again? Okay, I think I remember. This spot is where we call our... forgot what we called it. The beginning. I just name it a random name. The original beginning. Which sounds like an epic movie quote. The original beginning. So let's say we're here, right, at M. Well, first of all, the base case is... so our goal is here, right? The stopping case would be if I find a number whose neighbors are all bigger than it. So 1 is bigger than 0 and 7 is bigger than 0. That's how we know we've found the minimum, because it's rotated in this fashion. Base case is my neighbors are bigger than me. And then you just return your current one. Okay, so if M, the value at M is greater than the value of J, then you know that you're not within the original beginning. So you want to move your I inwards like this to M plus 1. So if M is greater than J, I'm talking about values here, by the way, not the index, then you search right. What happens though if, say, your M is let's say hypothetically that your M was here. Then you know that you're actually inside the original beginning. and you've established that your neighbors are not bigger than you, so you haven't hit your base case yet, so you search left. Yeah, you are in the original beginning, but you haven't hit your base case yet, so you have to search left. And you move your J like here. Yeah. If M is less than J, search left. And then you keep doing this until you hit your base case, or I is less than or equal to J. Yeah, that should be the solution. Let me see what I did last time. Okay, right, I have a left pointer and a right pointer. While left is less than or equal to R, find the midpoint. This was my base case. If I even have, if my left neighbor is inbounds and it's greater than me, that's this Boolean. If my right neighbor is inbounds and it's greater than me, that's my right, that's this Boolean. Stop case is the AND of these two Booleans. And else, if M, the value at M, is greater than the value at R or J, then you search right, increase the left boundary. Else you search right, increase the right boundary, or decrease it. Else you return -1. Okay, I think I got it. Search in a sorted array. There is an integer num sorted in ascending order with distinct values. Prior to being passed to your function, nums is possibly rotated. Right, it's rotated. Given the array nums, after the possible rotation and an integer target, return the index of the target. If it is in nums, or -1 if it is not in nums. You must write an algorithm with log n runtime complexity. Yes. i.e. binary search again. This one was kind of different though. Let me screenshot it again. Okay, we are trying to find a number. Let's say the target is 0, like in the example. Let's say this is our target, 0. We have I and J on the sides, just like in regular binary search. Okay, the midpoint is here. Should we put our midpoint there? Okay. So there's always this chunk where we can call our sort of sorted section. Sorted section. If, say, I is less than M, because these are the only 3 values that you know, right? I, M, and J. You only know the values at these indices for now. If I is less than M, then you know that you have a consecutive portion of increasing integers. So that means you can easily do a regular binary search here. So let's say your target is 0, right? So you can be like, is 0 between 4 and 7? No, then that means you search right. Yeah. So base case, does the value at m equal your target? I'm supposed to return the index, right? So you return the index. And else, this is where it gets kind of complicated. So if my sorted section is on the right, holy, I need to improve my handwriting on tablet. Okay, if your sorted section is on the right, like in this case, because your sorted section can't be this section, right? 7 is less than 2. So this cannot be a portion of increasing numbers. So if your target number is within the sorted section, then you search left. Else, you search right. If the sorted section is on the left, because let's say your m is like here, because then you're like, oh, 2 is greater than me, but me is not greater than 4. That means I have a increasing section here that I can easily determine the range of. So, is my target in the sorted section again? Then you search right, basically backwards of the clause above. Else, you search left. And of course, in the beginning, you need to sort. Wait, you don't need to sort. It's already rotated for you. That should be the solution. Let me see what I did last time. Okay, left pointer, right pointer. While left is less than or equal to r. What is my base case? If m is equal to target, return that index. Right, our sorted section is on the left side. If L is less than M, okay, so we swapped sections here. Whoop. So this is referring to my bottom section here. If sorted section is on the left side, if the target is within range of the sorted section, search target on the left side. Did I mix these up? Sorted sections on the left. Oh yeah, I mixed it up. Left here, right here. Right, if the target is on the sorted section, then you search in the sorted section. Oops, my bad. If target is on the left, search left. Right, search right. And then the opposite happens here. Return -1 if you can't find it. Yeah, okay. Oh. I also remember the greater than or equal signs got me a lot here. Because when we're comparing ranges, we need to do less than or equal to with the equal sign. Because the target could be on the boundaries of the ranges too. that's still fair game to be searched. You don't need to do it for M, because we've already guaranteed that M is not equal to target, so you don't need to search there anymore. Threesome, this one was not that bad. You had, should I even do a new layer for this? You basically had a pointer I, let's say this was your array, and then a pointer J and K. You have a sorted array, so if you want your sum to be bigger, then you increase J. If you want your sum to be smaller, then you decrease K. And yeah, every time you find a solution, if you can still increment J, you increment J again, but make sure that you skip duplicates, i.e. elements are the same as the one you just used. Same for I, skip duplicates. That way you prevent duplicate answers. You don't need to worry about that for K, because if I and J are different, then the triplet's already different. You can't, like, yeah, the triplet will already be different. Let me take a peek at what I did. Yeah, you sort it first. You have an I. Every time you increment it, remove the duplicates. You have a J, you have a K starting at the end. If sum is too little, increase J. Else if sum is too big, decrease K. And oh, that's the base case, which I forgot to write. If you've got your sum, which is 0, then you add the current result, and then you increment J to prevent duplicates. Okay. Container with most water. I think this was just greedy algorithm. So it's kind of like binary search actually. Well, not really. You start with I on the side here and J on the right side, and you're like, oh, the left side is screwing me over. So I move my I inwards, and then you take the product again, and then you keep closing in the shorter column. Yeah, maintain the current height, maintain the best. If L is less than R, increase L. Else, if R is less than L, increase R. Okay, those are all the array problems. I'm glad I, in general, didn't forget too much about them. I think next time I'll start dynamic programming. I don't think you come across binary problems too much, or like bit manipulation in coding interviews, so I'm not sure if I'll do the binary problems. If I turn the sum of two integers without using the operators plus and. Yeah, I don't know if I'll do the binary problems. Probably just move up to dynamic programming, which is always kind of fun. Alright, that went by a bit faster than I expected. Okay, I think that's it for today's review stream then. Thank you everyone for coming. I will see y'all tomorrow with dynamic programming, which will be fun. Alright, I have something at 10 o'clock scheduled too, so I will hop off and prepare for that. Bye guys.